Hi there, great to meet you all. My name is Ernesto Salas. I run the networking business for AWS in EMEA. A little bit about me, not too much, because I only have 20 minutes. I've been doing networking pretty much my entire career, around 10 years now, from telco networks to enterprise, data center, and now cloud networking. Within those companies, I've been doing a little bit of everything again. So from support to operations, implementation, and now I've been given the task by AWS to make networking attractive, right, for you folks. Because thankfully, like thanks to you, William, you gave me some segue into this. Like security and networking, they go hand by hand. Like usually developers and platform teams see us as a blocker. You know, we're not the fun people, we're like the underdogs. Like no one wants to deal with us when building their apps, right? So looking at the agenda, just going to give a little bit of background. I like storytelling when giving presentations. I'm not going to spend a lot of time there. And the rest of the topics, they're all going to be a little bit cloud related. So I work for a cloud company and I'm going to give the networking cloud angle on things. Now this is just going to be a teaser, right? So this is my first time speaking at a community event here in the UK. But if you would like to learn more about any of these topics, then just feel free to tell the organizers, and then I'll for sure prepare a deep dive presentation on any of it, right? So I'll cover background networking today from the cloud angle, as I said, then how to build global networks as code or as a service, and then how we're trying to simplify application networking for developers and platform teams. And then at the end, I'll just give you a teaser on Amazon's Project Kuiper and how it fits or converge into the network as a service story. Background. So I talk to customers a lot. And when I say that, I don't mean from the AWS standpoint, but as a network engineer. I've been talking to my customers, which tend to be the application owners, right? So when talking to customers, you'll see some of these quotes, and if I ask you now here in the room, like, what do you think about networking? You'll say something like this, right? So yeah, you know, it's like it's complex, difficult to maintain, often expensive. Like those guys, they are like difficult to deal with. Whenever we want to build an app and we have to reach out to the networking/security team, it takes a lot of time for us to get it implemented, right? So it basically is the opposite of what cloud enabled for developers, which was accelerate the pace of innovation. When you think about networking, it's like a blocker for innovation, right? Now, but how did Amazon build the largest network in the world, right? Like quite literally the largest network in the world over the past 16 years. So it's a very marketing-ish slide, but if you see every one of those like white lines there in the map, each one of those, it's an actual fiber cable that we have deployed and that we operate and maintain. Right? How did we do it? Just took the DevOps concepts that you're all familiar with, and we just stamped networking on it. Right? So similar to, like, Will actually stole my punchline. So I'm thankfully I didn't add there like net DevOps. But it's kind of the same, right? So we tried to make it flexible by applying those methodologies into networking. But obviously, this is not like that easy. It also required a lot of investment in people and in CapEx, right? So it takes a lot of money to implement transoceanic cables. This is a picture of one of those. I think it's in Japan. It's called Jupiter. Now, as we were creating this network to maintain our cloud business, we also learned that we were bound to the development life cycles of our vendors, right? So the networking vendors, the traditional ones. And those life cycles were too slow for the pace or the customers were asking us. So we had to build our own custom software and hardware. Right? Some of it, it's the Nitro systems. So if you're familiar with AWS, some of our instances, the vast majority now, are powered by Nitro. Nitro are our own silicon like cards, and we offload all of the networking and security functions to it, right? So you get the most out of your host. So this is the stuff that we have been developing on the networking side in the background, right? We're not really talking about it a lot. I'm trying to fix it. And But traditional companies are not technology companies, right? So we are a technology company, so we can spend time and money on innovating. But traditional companies, they just want to consume this, and they don't have time to be creating their own custom stuff, right? So how does networking look like today for them? And I'll ask you to take this for a second. I've practiced all afternoon how to say that word. I think it's skeuomorph or something like that. But think of it as using a new technology. It's adopting the image of a previous technology. So easiest example is a floppy disk as a saving icon for Microsoft Word. Right? I just keep that in mind. I'll come back to it in a couple of slides. Now, networking today. Very high level, very simplified view. Data center connected to on-prem, branch offices, you call it. And now multiple cloud providers, most likely. Let's just zoom in into the cloud side, right? So as I said, I'm going to talk to you about the cloud angle. Now, if you zoom in into the cloud side, let's talk about AWS. You don't have to be familiar with it. We'll just cover here an example, which would be Transit Gateway and VPCs. So if you're not familiar with a VPC, think about it as your isolated piece of the AWS cloud where you can deploy virtual machines or EC2 instances, right? Now, companies ended up having multiple VPCs. So at the beginning, we thought that you would actually just need one, like 16 years ago. And companies called us and asked, no, we want VPCs as an isolation layer for our business units or teams. So we were, okay, let's just build a transit gateway that allows you to connect thousands of VPCs. Now, if we zoom in on the transit gateway, you can think of it as a virtual router, right, or router. And it resembles a normal router. So route tables that connect your VPCs, and they are isolated per environment, maybe. And then you can have propagation between these route tables. And it ends up being more or less a traditional router, right? Now, we did the same with other constructs. So you came to us as a customer and you were like, yeah, we need some NAT. Okay, there you go, NAT gateway. Yeah, so we need VPNs, VPN gateway. Load balancing, well, elastic load balancer, right? Now, all of these services were built on top of custom software and hardware. So actually, the ones for the service that I mentioned, it's called Hyperplane. It's public information. You can go read about it. It's pretty cool. It's like a distributed data plane system. So it's pretty cool technology, but then we put a logical wrapper on top of it to make it look as a service that we felt familiar with or comfortable with as network engineers. Now, what happened is that you ended up having to be a networking wizard in the cloud. And you already had your networking wizards in your data centers, and now you needed a cloud networking wizard. But why? Then coming back to this skeuomorph thing, right? So we wanted to talk to network engineers and networking teams, and the way to talk to them was to make it familiar, right? So we could not walk into a customer's office and be like, yeah, we built Hyperplane, and try to explain how that worked for a bank. Right? So we had to transform it into concepts that they felt familiar with. Right? Now, we're trying to challenge that way of thinking and way of developing services because it just doesn't make a lot of sense. Right? And that's when I go back to the title of my presentation where we say network as a service. So the idea is to try to shift that mindset, that's my job, try for you folks to start thinking about networking as something that's more attractive, that enables the business instead of something that is blocking the innovation. How do you do that? Just using buzzwords like network as a service, consume it as a service, consume it as code, like you call it, right? But you basically just plug it into a CI/CD pipeline. One of it is Cloud One. Cloud One takes advantage of this global network we built, and then allows you to consume it as a service. How? By creating a core network. So you can create a core network, which is just a logical wrapper that will allow you to, let's say, push your changes through a core network policy. Now, the core network policy is probably the most important piece in the entire slide, because it's going to be the difference between that skeuomorph of a transit gateway and a new way of consuming networking for platform and development teams. What can you put in a core network policy? Well, you're just going to tell us through code how you want your network to look like. So we have 25 plus regions, and you can tell us, okay, this segment, which is an isolated domain, should be spawned in 3 or 4 regions, and this other segment needs to spawn every other region. And you can tell us also through code how you want those segments to behave with each other. Right? So you are just telling us through a document, a JSON document, how you would like your network to be implemented, and then we take care of all of the routing and implementation in the background for you. Similarly, you would still have the split in teams. So you still have development teams, platform teams, and the network admins. The network admin would take care of the core network and the network policy. The development teams and platform teams can just receive a tag. And they can tag their VPCs with that, and then based on the tag, we can just plug it into a segment, and that VPC would inherit all of the networking and security policies that the networking admin team set. And that expands to on-prem as well, so SD-WAN, VPNs, etc. So you can build a global network literally in minutes with a file that is not longer than this. How does the file look like? It's just a JSON document. So it's nothing flashy, but very handy. You just tell us what to do with the network, and we implement it. Now, what's the difference? Being a file, you can just plug it into a CI/CD pipeline, so the networking CI/CD pipeline. And then you can roll out a new version in your test environment. And then if it doesn't work or something breaks, you roll it back. Or you can push it directly into production, see how it behaves, and roll it back, right? So CI/CD pipelines, you know more than me about DevOps and how this works, but now you can implement your network and plug it into it. But Cloud One is just like attacking a very specific use case, which is creating global networks. Not everyone needs a global network, so it's not relevant for everyone, but everyone needs a local network, like a regional network. So your regional network still looks a little bit like that. For that, we came up with a new service that we announced 2 months ago during re:Invent in December, which is Amazon VPC Lattice. Now, there's no skeuomorph for me to help me explain to you what Lattice is, right? So I'll just do my best. I'm still getting used to the concept of it. I've sat down with the service team multiple times. I did my best to simplify it into a couple of slides just to be able to get your curiosity and attention, right? So if we look into Lattice, we have 4 main components. So a service network, then we have a service directory, and security policies, right? And then you can guess already like which team is going to own which. If we put the networking admin hat on, the network engineers will be in charge of creating a service network. Now, the service network is not more than just clicking create and ticking a checkbox, right? So we take care of all of the actual like network implementation in the background for you. And then the networking team will decide, okay, this network is relevant for these accounts and maybe these VPCs, and that's it. So similar to Cloud One, like they build this centralized networking construct that application teams and platform teams are going to plug into. Then on the development side, you own your service and you define your service, and you can deploy it on virtual machines, you can deploy it on Kubernetes, on serverless technologies, it doesn't matter, right? So you now have the freedom to implement your service where it best suits you as a development team without having to think about IPs, overlapping IP addresses, and things like that, or having to talk to the networking team. You set the routing policies, similar to how you would implement an application load balancer. And then you register your service to one or more service networks that have been shared with your account. And that's it. Then services connected to the service network will be able to talk to each other using DNS and discover each other using DNS. So it's a discovery slash network infrastructure as code managed service. So you, as a platform development team, can forget about IP addresses and having to implement all of those networking constructs that we saw before. Now, security, because it's very important, goes hand by hand with networking, can be implemented in both the service network and in the service itself. So the networking admins can worry and be sure that the company level policies have been applied to the network, whereas the service teams will make sure that their service is secure to their security standards. So it's a little bit creating a balance between the responsibilities on the networking slash security side and the developers. And Project Kuiper, how am I with time? Good? Cool. So Kuiper is not AWS, it's Amazon. So Amazon, the big company, owns several companies, including AWS. Kuiper is another one of these. Kuiper, I think the name comes from the Kuiper belt. I'll allow you to Google that. Kuiper, it's a project that have been developed and it's been operated by Amazon, where we have been already launching a set of satellites, right? The main goal, or the overall goal of Project Kuiper, is to bring fast and reliable broadband connectivity to less privileged areas of the world. So we are all very privileged here in London, in the UK. We all have really good internet connectivity, but when I was back in Venezuela and I was trying to play my online competitive games, I used to suffer and struggle a lot, right? So, and that's a very silly example, but you know what I mean. Now, if we look at the numbers, you'll see that over 1 billion households have no access to reliable or no broadband connectivity at all. And then Project Kuiper is aiming to solve that, right? So creating a global network that will be able to provide you with this reliable connectivity no matter where you are. Now, households are not the only customer or target customer. This would also be offered to enterprise customers, or, like, as you can see, transportation. So the target customer range varies a lot, being the main one households and providing broadband connectivity to them. Now, very high-level overview of the architecture. Unfortunately, like, I cannot share more details right now. I will be in the future, but think that we will ship terminals and an antenna for you. There are a couple of, I can share more information, but not today, but I'll share more information around the antenna and the terminals themselves that you will use to connect to the satellite system, right? Then on the other side of the satellite system, the connection will come down into one of the gateways, and the gateway will connect into one of our interconnect points, or points of presence, right? Now, from that interconnect point, then we will plug into your enterprise company, or to the internet, or to cloud services with AWS. And that's where these two topics converge, right? Because the networking infrastructure used by the Kuiper team, it's running or leveraging AWS's network infrastructure that we said before. So if we're running the largest fiber private network in the world, and we were still not able to deliver that network all the way down to your household, now with Project Kuiper, we would close that gap, right? So think that I told you, with a JSON file that is not longer than this, you would be able to create a global network in minutes. Like, imagine what you would be able to do once Kuiper is plugged into it. Cool. That's it.